This week, we discuss major identities and microservices. In the news segment, things get fuzzy for kernels, passwords go plain text, dependencies become dependable, and more. Stay tuned for Application Security Weekly.
This is a Security Weekly production. Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies, protecting over 7,500 applications and 150 billion production requests per week. Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences patented technology protects any application against any attack, with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at signalsciences.com/PSW.
Welcome to Application Security Weekly. This is episode 63, recorded June 3rd, 2019. I'm your host, Mike Shima, and I'm here with John Kinsella. Hey, John.
Hey, Mike, how you doing?
Pretty good. John is joining us across space and time right now, in London, I believe. Is that right?
Yep, I'm in London for this week. I'm out here for some Qualys stuff as well as to see InfoSec Europe.
Awesome. One of my favorite places. Register for our upcoming webcasts with LogRhythm, Domain Tools, and SaltStack by going to securityweekly.com/webcasts. If you have missed any of our previously recorded webcasts, you can find our on-demand library at securityweekly.com/on-demand. Security Weekly is returning to Vegas this August for Black Hat and DEF CON. If you would like to request a briefing or sponsor an interview on site at Black Hat, please go to securityweekly.com/booking and submit your request. So we don't have a guest today, so I thought we'd turn to some DevSecOps topics. A lot of times, in the news especially, we talk about bugs and breaches, which are a really good way to touch on anti-patterns and to talk about how we can learn from them to improve software. But John, this time I thought it might be equally interesting to talk about what do good design patterns look like, and what are these design patterns that have emerged from cloud native environments or coming from that DevSecOps principles of not only developing code, but actually owning it, maintaining it, and seeing how it works in production systems.
You know, I think we're at a really interesting time. If you look at the last, call it 2 or 3 years, this cloud native thing has been happening. Personally, I'm starting to see two patterns here. What is a lot of folks are asking me really what you want to talk about here today, what we want to talk about of what's the right way to do this stuff. And then the second part is you're starting to see a lot more interest in really making that CI/CD more efficient. We've had, Jenkins has been around for probably longer than I want to remember, but we've had these tools for a long time, but now the interest in them and not just having them, but using them as efficiently as possible is really starting to get on people's mindset. So yeah, it's a good topic to chat about.
Yeah, and I think, the last several episodes, at the very least, we've been talking quite a bit about Kubernetes and containers. Those always come up because those seem like one of the basic building blocks of these services. And at one point, we also talked about Envoy, an open source project that came out of Lyft, which was a way for containers to talk to each other. And then just this past week, came across an article from Facebook that talks about essentially how they have their services identify each other and authenticate with each other. So it's sort of this progression of here's a little service, sandbox in a container. Now these one and many containers need to talk to each other, but we need to throw, so there's a little bit of DevOps, but now we need to throw that security angle in there to make sure that we're, have mutual authentication. So there's some trust in between all these services that are talking to each other, and that we can actually manage that trust in a scalable and efficient way.
Yeah, two of the bigger points I'm seeing, one is the authentication of those microservices. The other one, which really pops on my radar a lot, is now that we are becoming more and more reliant on who am I kidding? Multiple microservices talking to each other over a published API. What's the security of that API? Should the authenticated user, presuming we're using an authenticated API, presuming is that user should he have access to all those API endpoints? Are we sure of the data going back and forth across them? Is there some amount of clarity around what's happening there? That's something that a lot of people are really starting to think about as the underlying infrastructure becomes smaller and smaller.
Yeah, and I think those are areas where it's still a very unsolved problem and interesting areas to explore. So the actual getting the data back and forth, we've seen, Google had its protobufs, and which are, a great way to have microservices talk to each other and not worry about what's the endianness of this CPU architecture, how do we deserialize, reserialize something, all these crazy things. And we even see that idea of that strong data encapsulation, even at the micro scale, to keep throwing around the micro word a lot, even within like Safari and Chrome, and using processor separation and using RPC to trade this data back and forth to minimize those classic vulnerabilities of off by one errors, buffer overruns, buffer underruns, etc., and start to talk about the more things that can be really consequential, like you were pointing out. Should this service even have access to data? And me as the providing service, how do I know that? Who's going to attest this for me? And in the past, I guess in the ancient history of networked security, there was MIT Kerberos, and getting into all kinds of funds of tickets and ticket granting tickets and service tickets and tickets everywhere. Everyone gets a ticket. You get a ticket. The more this Facebook article called out was they did start along that because it was still a well architected security design, but not necessarily the most efficient, and nor was it easily scaling, because it's one thing to have a service designed on paper, it's another thing to actually implement it. And so that's where we saw companies like Google, like even Facebook and Yahoo, for example, moving to these like certificate-based service identification. So that way you can use TLS just to say, yep, here's my certificate. This proves who I am. It's signed. It's got this nice chain of signatures on it that proves all the way back to whatever internal certificate authority can prove that I got this certificate. And therefore, since I have it, at least please talk to me. So that's sort of where we are now in trying to figure out that let's talk to each other and trust that we're talking to each other in a good way.
Yeah, I want to back you up half a step, because I think there's something important there to at least shine a light on for a second. And that's that, and I'll say, I frequently come off sounding like I'm not the biggest fan of Google. They do a lot of really great stuff. And I think here's one example, talking back about protobufs and those type of things when they were coming out with them. I think Google was really, they had their eyes in this particular area further down the road than I think a lot of us did, right? When they started coming out with, because protobufs had all those things you're talking about, but it's also really lightweight. And then they were doing something similar around, I forget the acronyms, but the ability to do a lighter weight HTTP request. So they really had their eye on how do you minimize the overhead into a lot of those type of things. They realized that we're going to be more and more network focused. I mean, that's sort of an obvious with the Chromebook and stuff, right? That was on their mind. But that really starts coming into play with the microservices. And the simpler and cleaner you can make those protocols, better chance of your security is around those. So yeah, it's been interesting to watch that. And then as you were saying, yeah, it's the, how do you, I was a big fan of Curve, but at the same time, that's not a lightweight, simple thing to set up, right? So how do you take some of those really great security concepts we've had from later year and then actually apply them in a way that is lightweight, easy to access, automatable, so you can store your credentials in Vault or what have you, some sort of an easily accessed system, which is fairly standardized in a more modern world. So yeah, those are really great things to be thinking about and looking at.
Yeah, and I think Speedy, for example, that was their that was like the predecessor to HTTP 2. And same with Google was looking at, how can we improve TCP? And that was where Quick came from, QUIC.
Hmm.
And even with TLS 1.3, again, that focus on something as simple as how can we get this channel established as quickly and as effectively as possible? Because when you get to a certain scale, you can actually track one byte of data across the network is this many, costs this many, cents or dollars. And even if it's just literally, fractions of a penny to transmit one, byte, when you start to get in talk about companies that have terabytes of traffic and storing petabytes of data, those fractions of a penny, go back to Superman 3, and I think that was where Richard Pryor was rounding off those pennies to make money. That's exactly what they're trying to do here is solve the same problem, but perhaps in a more in a less criminal manner. And see,
Wasn't that in one
but
of the oceans as well? I think also, now that I think about it, wasn't it Oceans, was it 11? Maybe
that
on Game
sounds
of
right
Movies.
too. Yeah.
A popular topic. All these, security experts out there, we just didn't realize it. Yeah, and I mean, it's. I think I think you and I are both dealing with some fairly large amounts of traffic in our day jobs, and yeah, there's two things to that. Again, one is it saves you money, saves you time. I'm guessing it probably. Not guessing. I know it saves on compute, right? If you're able to set up and tear down those connections, that's a little bit easier. Then yeah, when you look at the cost of how many of those you've done over a period of 6 months or a year, that it makes a sense to think about this and architect it correctly up front.
Yeah, and what's really neat too is getting down into a little bit of the weeds of the technical implementations. For example, what Facebook was describing and related to TLS. So you can have that initial handshake. If you're using TLS 1.3, it's only what is it, like 3 packets back and forth completely, or even a single packet to get started. Whereas the old school, we'll call it TLS handshake, was like a 5-step handshake to get going.
Yeah.
But one of the neat things was the session tickets so you can do session resumption, and there before, kind of to what you were saying, let's be nicer to the CPU, and rather than go through that asymmetric key, crypto algorithms that are a little bit more CPU intensive. Let's go straight to that symmetric key, like within AES, and pull out what's might be even native implementations within the chip itself. And to do that, we're going to encrypt these session tickets, so that way these services, rather than even just having to re-exchange their identities and their X509 certificates, they can just say, hey, can you decrypt this? Awesome. Let's start going, because this was this last key that we used. The catch there, of course, being, as an attacker, if we start to talk about like threat models, what if I go and compromise some of those, session ticket keys, so that way I could just restart and skip that, restart in the middle, so to speak, and skipping that initial handshake process, or skipping that initial identity proof. So there's some really cool things that come out of here in considerations, as well as when you were calling out those aspects of like being nice to the CPU, just being more efficient in the networking. They were also talking about in that DevOps mentality of engineering and engineering feedbacks, what they were seeing with MIT Kerberos is the service seeing very bursty communications or very slow start communications, and the services and the thread pools that they were trying to do to manage those types of two very different traffic patterns were causing lots of engineering nightmares or headaches. So it's also interesting just to see, there are pure operational impacts to how we want to try and deploy security at scale.
Yeah, that's you led me right where I wanted to go. But so let's see. First, on the operational aspect, I mean, yeah, if you think about, or not think, if you interact with any network engineers at some of these larger organizations, they tend to care a lot about being able to model and have a solid understanding of the type of data that's being thrown at them. So if suddenly you have a very peaky traffic which is bouncing up and down, and makes it much harder to troubleshoot what's going on, and allows them to actually model and make sure that they've got the bandwidth that they need. And not just bandwidth, but also the packet per second, which is some people don't realize, but a lot more important, right? When you start dealing with some of this stuff, especially with IPSs. So where I want to go with that, though, what I think is interesting as we're talking through this, and this wasn't something that we thought about earlier when we were thinking about this topic, but the operational aspect of this is something to be kept in mind as you start moving towards newer, more lightweight protocols. If you happen to have the IPS in place, or some sort of I'll say a proxy just to keep it generic, right? But something that's actually doing traffic inspection, IPS, IDS, pick your poison. They have to be able to understand if you're doing offloading of that TLS either on the load balancer or on the sniffer, or you're putting certificates on the sniffer, one of these ways to be able to see what's going on there, those devices suddenly now have to be able to support those newer technologies. And I think frequently when people buy those devices, they're intending those to be left there, in good working order for 5 years, possibly more. So that's something to keep in mind is both, do you have, what's the phrase they use in the stereo world? Forward, I'm going to forget, but there's a phrase they like to use in high-end stereo. It's your equipment can actually be upgraded down the road. Something to be kept in mind for the networking gear as well.
Yeah, and that's a really good point to bring up, because it also kind of speaks to where are these DevSecOps teams, or where do they want to place their monitoring infrastructure? So if we're saying good things on the one hand, for example, let's encrypt all the traffic, but if we start to go into even TLS 1.3 and we have forward secrecy, so intercepting traffic becomes that much more complex. Devices it's not necessarily going to play well with these devices out of the box, or how they've been sitting around, as you mentioned, like the last 5 years. They're going to have to adapt. Maybe there's a move to push that monitoring, that detection right actually into the endpoint itself. So that's into the container, and that's where we were talking about watching syscall monitoring, syscall firewalling, and actually we haven't even used the term firewall in this whole discussion yet. I'm going to guess that's probably because they're kind of useless right now, or they're not really providing much value.
That's an interesting one. I see where you're coming from in the case you're making, because for the last 10 years, almost everything goes over 80 and 443, right? So what's that box for? Right. But at the same time, we're seeing a lot of it. Istio is the sexy kid on the block, or excuse me, the sexy adult on the block for the last few years right now. And that is, to a way, has a firewalling component of it. I have, and this is really sort of a religious thing, right? Do you put your IDS in front of the firewall or behind the firewall? When you start thinking about, do you put it inside the container? And this is something, we've thought a lot about this one. My own personal opinion, and I don't care what vendor you use, is I don't want the sniffer inside the container. Because if you have, say 20, 30, 40 containers in a box, and each got some sort of libpcap running, you just burned up, we were talking about saving cycles, you just burned up a hell of a lot. So there's a balance there when you think about how do you design this again, and how do you actually think about this? It's if you think about, especially if you're using public cloud, if you're on something like Fargate or what's Azure's container instances, you can't trust your neighbor on the same box. So you want to be able to encrypt and secure the traffic leaving that container and coming into it. But at the same time, you need to have both some level of visibility into what's going on at the network. So how do you do that? Do you put something inside the container? Do you maybe have the ability to flip your network stack into an easier to troubleshoot mode for a little bit? I know that's also known as making it less secure, but sometimes that needs to be done. So it's interesting to think about where's the trade-off around that. What do you do? How do you do that? And I think it's going to vary per organization. And probably the people who really care about that, they're not going to be using the public clouds. And it comes back partially to the container thing. Containers are wonderful. They provide isolation to a degree, but the folks that really care about, and this is, we're over the bell curve, and this for the top probably 10 or 15% in my mind on the security conscious side. They're not going to be running in shared infrastructure like a modern Docker container. They're going to use something more like micro VMs or something like that actually provides hardware isolation around them. but still is something for everyone else to think about, I think. And how do you do some of these things we're talking about from an operational point of view? It's nice if our services always work perfectly and they always communicate correctly. You never get strange error messages about not being able to connect to a database or when you're other microservices. But at some point, usually back in the real world, you need to have some level of troubleshooting these things.
Yeah, that excuse me, that's a great point about the let's not overload all every single container with just the replicated copies of the exact same thing. Because yeah, why sink down the CPU when maybe we just could do a little bit better application layer logging to at least help with that aspect of debugging. So we can instrument the code a little bit better, get the data back to a central store, do some analysis. And then maybe it's here's where we maybe should start talking to some other people too. Put a little note down for some interviewees to go look after. How much interesting do we just need NetFlow data versus a full PCAP? So maybe we just need metadata about systems talking to each other and where's the anomaly. And I'm studiously avoiding any mention of ML, with an AI to try to detect, these anomalies. It's more of just like this service is supposed to go and fetch keys to encrypt data. Why is it suddenly, why is the data direction of data suddenly it's sending out a lot more, or it's getting a lot more inbound traffic than outbound? Something that's very obvious, something that an if-then statement or that, regex-based machine learning can figure out. That type of thing is what I'm aiming for.
I think there's a lot of good which you can do with, and since we got video, I have to do, anytime I say this phrase, I usually have to have the jazz hands, machine learning. But every time for those on the audio, I'm doing a little bit of sort of rainbows. But yeah, there's things that ML can do, I think, which let's not try and say that it's going to be the magic unicorn that's going to save the world, but mathematical. So as far as I'm concerned, my viewpoint on ML, it's been changing over the last few years, and really sort of what it is nowadays. I think of, and we're really off topic here, but I think of machine learning it's really math, right? So can you model what you should be seeing in your application in a reliable way that's reproducible? So I'm not talking so much right now about, we can do detection of 0 days, all that type of, let's leave that away. But at the same time, okay, yeah, this application usually talks to a database, it talks to your service mesh, it talks to 2 or 3 other things. That's something from an operational point of view that you should be able to recognize that pattern fairly quickly and then be able to say, hey, I haven't seen, we usually get 50 packets per second, it's dropped down to 2. Maybe we might want to have one of the humans take a look at this. So that type of thing, I think, is open to be supported pretty well on machine learning.
Yeah, I think so. And I definitely agree with that in terms of constraining it to an area with good, rich amounts of data that are relevant to a very narrow problem statement and finding that solution. I think it was one of the other documents I was reading. I think it was about, might have been Fizz, which was Facebook's implementation of TLS 1.3. And they were saying they had a anecdote about they were seeing handshake errors, but very, very small number of them. And they didn't use ML to get down to this, but it was the type of thing that would lend itself to that type, I think, of operational detection and anomaly analysis, because it ended up, they discovered that a particular CPU, an instruction set was just wonky on it. So when you have, data centers with hundreds of thousands, literally, of systems, you're going to encounter weird hardware problems. Even Google, they had a paper a long, long time ago about disks and uptime. And once you have this massive amount of data, you start to see these mean time to failure. When does this hardware actually go wonky? What are the really weird corner cases where actually the planets do align and it's a full moon and the weird thing happens that you never expected it to? And those are really cool learning situations. And yeah, I guess I went off topic quite a bit there, but it's cool engineering stuff, and it's access to data that you can learn from. And I think that's how I would also summarize what you were describing in ML. It's math.
Yeah, that if I can remember the podcast, something in the last few months, I want to say it was Planet Money on NPR. They did a segment about cosmic rays. Basically, well, it started off where a voting machine in Europe had a pretty significantly high miscount in votes, and as soon as I heard it, I was joking in the car. Oh, it's solar flares, and my wife's like, haha, you're funny. And then it turns out it was solar flares. But that type of thing, it sounds really simple. I'm quite happy I wasn't on the team troubleshooting that over at Facebook, because that sounds like not my idea of a good time. But it's something you gotta as you say, when you start doing this stuff at large scale, there's only a handful of folks folks or organizations in the world that are doing it up there, but they run into problems that hopefully most of us won't see anytime soon.
Yeah, I think that was a great way to bring us back full circle, because we started talking about, this article was a bit of a seed about how Facebook is handling mutual identity and mutual authentication using TLS. So I think we've hit also election, how the sun is after our election security, and we called out some of those to try to summarize a couple of the key points too. Containers are, those are the easy modern ways right now that we, as I wouldn't even say the security community, I would open it up to just like the engineering online community, computer sciences community, our sandboxing services, having those services be orchestrated at some grand level with something like Kubernetes, and then using these tools like this mutual authentication, so that we actually have X509s passing, identity around with strong attestation. And what I want to do is maybe last couple minutes turn towards sort of a forward-looking idea of what can also, if we can have services that have strong authentication to each other, what else might we try and build on that? And just to give you an idea of what I'm thinking of, what if we can also say this service can attest that it's the binaries that it was built with match the source code that match this one particular Git commit from this one particular branch, and therefore you have a high degree of trust that not only does the service say, attest who it is, but it has a strong attestation that it actually hasn't even been tampered with either. And I don't know if there's things like that would start to jog your mind, John, about other things that we might see in the future.
Honestly, not off the top of my head. I think it's, at least from what I see, it's an area which, I'll back up one step. I mean, it's really interesting to hear more and more folks talking about sandboxing in 2019. So people are starting to, and it's partially, as technology fads come and go, but people are starting to understand and realize that you can provide these things as a service, but still, as you do that, you need to think about, the concepts of multi-tenancy and API authentication, and being able to secure these and provide these things at scale within an organization. So I think that's really great to hear and see. But nothing particularly comes to mind right now. Like I was talking earlier, one of the things I'm interested in is really around how do you something like an API gateway as to maybe not the service mesh itself, but something that's able to actually inspect what's coming between, two separate services. And is this something which is kosher, or someone to try and do a little more sophisticated attack? And that seems to be something that a lot of folks are really interested in, being able to have that peace of mind, so to speak, that part of the application has been attested to.
Yeah, that's a really good point, because it also reminds me that I got stuck a little bit too much on, I usually try to avoid this, is just on the technical aspects. Here's the design and implementation details, sort of how is the application, how are the services being built? In other words, what does it look like for their CI/CD pipeline? They're getting deployed. How are they doing mutual authentication, et cetera? Repeating those words ad nauseum, but it doesn't really speak to what is the service actually doing. And that, I think, is a great point that you made. Is great. We have an API. It provides data. It collects data, but Is that data being misused? Is it collecting too much data? Could we actually narrow it down how much it's collecting? Or can we see that that data is being exfiltrated by something as simple as an IDOR and somebody is rotating digits, or it has weak access controls? And so far, sandboxing, encryption, etc., isn't really protecting us against those particular scenarios, and those we should not ignore at all.
Yeah, that's it's funny. I don't I haven't thought about exfiltration from a microservice point of view. I usually think of that something more sort of, and I think a lot of the products are focused around exfiltration from an IT, or a corporate IT point of view. Is someone trying to copy something out on the G drive, the sort of the low hanging fruit of the world? But that's interesting to think about. If you start, I mean, you're almost what you just described there, sort of a side channel data exfiltration, right? Really hard to track that stuff down, but it's definitely something. As we go back through this and think about not just modeling the threat, but modeling how that application should be used. Do you need to be providing all that data? At the first time, think about, and I've seen this a lot in the startup world. The first time someone, when they're writing an application, okay, we need to get this thing from the database, select star, then go and use one field out of a crazy large record. And then sort of, usually it's done for performance reasons, but there's also a security value in there. Did we really need to grab select star? Or maybe we just wanted a single particular field, and let's not even expose the application to the rest of what's there to use.
Yeah, I think that's a great point. And I also think that's going to use that as a segue to say we're going to have to select star into the news coming up soon. So that was a great conversation, John. Thanks again. And we're going to take a quick break, and we'll return with news of the week.